Okay, so welcome back, CIS 157. Our last project is posted, it's assignment 8. And this is something I'd like to make sure that we talk about today because I know that you guys already started even programming it. But this is yet another example of this almost fits perfectly the format that I'm looking for in CIS 123 semester project. You need to, for the functional specification and the requirement, you need to produce a similar document. So this is yet another example if you're looking for a sample, right? So airline flight schedule. So it's somewhat simplified compared to commercial grade application, but it has some pretty decent elements in its description, and we need to discuss this, and we need to come up with some plan to how to attack this challenge, and what do we do first, and what do we do next. Obviously, I did ask you to look over this, but nevertheless, let's go over it. So here's the introduction. And it says this is our final project. So then we need to have an application that keeps track of airline flights. To be able to keep track of airline flights, we need to recognize airlines, aircrafts, scheduled flights, I suppose, and also we need to put together something that functions as a flight schedule. If you're beginning to think ahead of what I just said and think, okay, maybe I should have these types of classes in my application, the answer is absolutely yes, of course, yes. The answer is yes. That's the classes that we're going to use in this application, no doubt. So, and this simply is structured, typically a description of an application may be using much more of a user-friendly language. But this is essentially structured so that it's as friendly as possible for you to read, the programmer. So airline information, right? So recall, we need to put together a schedule of flights. Flight needs to be assigned an aircraft, some timetable attributes. But an aircraft obviously belongs to an airline company. So airline company is another piece that we need to have. And then we also have the airports, right? So if there is a departure from someplace and arrival someplace else, and all of this needs to be essentially made a working application. So airline information. Each airline needs to be identified by its name. All right, so the name will be part of the airline data attribute. But they're also going to be basically an airline ID, such as DL for Delta. Since there will be already so many different classes, not so many, but a few different classes, which will be used differently across the entire application, I am trying to simplify it and just say we can store the aircraft information along with airline, simply by assuming that an airline owns only the fleet of one kind of an airplane, right? One type of aircraft. You can actually disagree with me and write code to make it different and be able to support multiple aircrafts. It's up to you, but at a minimum, to make it just acceptable for format of our class, it's just that we can remember the type of aircraft with our airline. All right, so it's as simple as possible at this point. So that's why we say, all right, there's the airline aircraft data is going to be described together in this handout. So we need to maintain the following fields: airline name, right? The code, that ID, DL, AA, whatever airline is. Aircraft name, model, make, whatever you can go wild with this. So you specify what this is. And we also will be storing the capacity parameters also with Airline, which is obviously quite inappropriate because most likely you'd like to keep the aircraft data separate. But to make it simple, we can just throw it in here and say this is a combination of both airline and aircraft data. Again, I welcome you to disagree with me and create separate classes for an airline information and collection of aircraft that it maintains. But at the minimum, we can store this with airline. Flights, right? How do we capture information about scheduled flights? We will say that obviously we need the code of an airline so that we know what company is the carrier. The flight number is something that we're just going to be inventing on the fly, entering flight numbers. Flight will have a status which can be scheduled, canceled, departed, or arrived. You can add to this list if you wish. Flight type, domestic, or international. Okay. All right. So to have a flight schedule, we need to have. I am assuming unique identification of a flight will be based on the combination of these two attributes: the code of the airline and the number. Fine, and some other additional information. So flight is going to be a class. Most likely airline is going to be a class. If you'd like to keep aircraft data separate from airline info, aircraft could also be a class. And that's pretty good. That's a good start. Now, departures and arrivals, right? So apparently flight also need to have those two sides, departure and arrival. So I think the proposition that I'd like to make is that maybe we can create a class named departure arrival info, right? We don't have to invent too many new, terms. We can just follow what we have here in this handout. So class named departure arrival information could be used in place of both departure and arrival because all of the data is very, very similar. For example, we need to specify the day of the week, right? So again, I'm sure that airlines can do much more sophisticated track of time and time zones and all kind of issues related to their schedules based on the weekly, bi-weekly, whatever, seasonal, and so forth. But in our case, we simplify it to the level of we say, okay, you want to have a flight, you tell us what day of the week, and we just basically will be assuming that it's going to be happening every time, during the week on that day. Simple. Departure time. We haven't started to talk about dates and times, but this is a clear indication that very soon, at some point in this class, we need to start talking more seriously about storing dates and times and other calendar-related information in our programs. For now, to make things as simple as possible, 24-hour clock is assumed, and we're going to be starting with 0, meaning midnight, so we can use an integer to store time. Integer is midnight, 100 hours will be 1 a.m., and so forth. 1200 hours is going to be the noon time, and 2350 hours is going to be set to be 11:50 p.m. So basically we have the 24-hour coverage by using an integer. We're going to apparently ignore time zones, international issues with any kind of like our flights crossing time zones. So we're going to ignore a lot of it, but anyhow, let's just start with something. We can always make our track of time, dates and times, I would think, in more sophisticated manner, but at this point, this seems to suffice for this, to get started with this project. So again, simplifying the date and time as much as possible, whereas of course in the future in a hopefully a near future, we're going to start talking about issues with calendars, holidays, days, times, time zones, and other things pretty soon. Airport codes should be stored with the flight departure and arrival, right? So for simplicity, we'll just let the system store the airport codes. Let's don't bother with airport names, but the friendly airport codes website gives us the list. So very good, right? So we're going to be capturing only, if it's Chicago, we have these choices, and so that's fine. All right, so very simple. So BOS would be telling us Boston local. Uh, now, we are not going to validate any of this stuff that the user will be entering. We'll just be assuming, okay, you give us some airport code, we'll accept it as a legit code. So it's just entirely up to the user to follow that. But basically, this is what we'll be expecting in terms of airport codes. Now, notice that day of the week, departure time, airport code, departure gate, we are going to store everything with that structure, with that class that we are trying to describe right now, departure arrival info. Let me save the segment.